Okay, the objective for this video is to decide if there's a relationship in the surface area of prisms that all have the same height.
So we're saying all these have the same exact height.
Right. And this one is a triangular prism. This one's square. This one is pentagonal or pentagonal.
Pentagonal, yeah.
This one is hexagonal or
hexagonal.
And this one is a cylinder with a circle top and bottom.
Could we call that a circular prism?
We could. We could call that a circular prism. Now, when I made these, I used the same size sheet of paper for every single one of these. So since surface area has to do with the material it takes to make the prism, right now the way they sit, their surface areas are all equal.
All of the walls.
All of the walls
are equal.
All of the walls are equal.
Okay.
Okay, so if I'm just going to compare these two first, I know that the sheet of paper was the same, so my walls are the same. So the only thing I'm really concerned about is if I were to put a top piece and a bottom piece on, whether or not those would also be the same.
Right.
So I'm really only comparing this triangle to this square.
Because if one is bigger on the top, it's going to be the same way on the bottom.
Right. So I'm just going to set this here, and why don't you try tracing around it on this little whiteboard I have here.
This is going to be an approximate.
Right, it's approximate. We're just kind of doing some estimating. All right, so now I'm just going to lay my triangle, and I'm going to line up at least part of it with So now I'm just comparing them. So what do you think if we take this little piece right here that's outside of the square, would it fit in any of my extra space in the square anywhere?
I think it's a little bit bigger than this.
It's a little bit bigger.
Not very much. But we could fill this one in.
Right, so if we filled this in here, then maybe a little bit more.
Can we erase this one here now?
Do we need a little bit more, or do you think that's pretty close?
I think just a tiny bit more.
So maybe over here a little bit?
Just a very tiny bit. There you go.
Okay. So then I'm going to take this piece here, and can I flip it around and put it over here?
Yep.
So I'm thinking it's going to take up about that much. Does that look about right?
Looks good to me.
I may have even overdone it a little there. So then I fill in here.
And where this is gone.
Uh-huh.
And we need to fill in the part that it already covered.
Right, we already have this covered. So that leaves...
So the triangle's all the green part.
Right.
And the square is the green and the white part.
Right, and so the square is clearly bigger than the triangle, which means the surface area, if I added a top and I added a bottom, the surface area of the square prism is going to be larger than the surface area of the triangular prism.
Absolutely.
So should we write that down?
All right. Can I use surface area, SA for surface area?
Sure.
The surface area of the square prism is larger than the triangular prism.
Right.
Okay. Now,
So I redid the square, and now we're just going to try to do the pentagonal. Let's see. So this time I'm going to try and see if the square is going to fit inside of the pentagon.
the pentagon definitely won't fit inside the square.
No. But I could definitely take this little tiny piece, and I'm thinking this piece over here and put them together. And where do you think we could put them right here?
Yep.
And then this can go away.
So can this.
Okay, and then just filling that in. I have this piece here.
That'll be definitely bigger than that.
Yeah.
Maybe we should just put it over here.
Okay. So does that look close?
Mm-hmm.
So then that goes away. And I already had all of this space in here. So the pentagon is bigger than the square.
Right. The surface area of pentagonal prism is larger than the square prism. All right.
So now I have the pentagon drawn on there, and we're going to try and get the hexagon on.
Okay.
So then I'm trying to get the pentagon into the hexagon, so this is overlapping here. So where are we going to put it?
Right here.
And then I can take this off.
Mm-hmm.
And there's this little tiny piece right here that I'm
Should
just
be a
going to
little
stick
dot
right there.
there. And this is just like a little tiny sliver.
So I'm just going to put it up there. So once again, I still have room left over because here's the part I already had before. All of this colored in. So I still have extra left over, which means that the hexagon is bigger than the pentagon.
Right. So surface area of the hexagonal prism is larger than the pentagonal prism, or pentagonal prism. Okay?
Okay, so now I have the hexagon drawn, and we're going to put the cylinder on top. All right, so I'm going to take this little bit right here, and I can
combine it with this little bit right there.
little bit right here,
And maybe right there.
and put it, and I don't know, I think there might be a dot right there, and we can put it right there. Does that look like I got it all in there?
Yep.
And I still have some room left over. I had all of the space in here already used up, but you can see there's still plenty of space along the edges. So that means that the circle is definitely bigger than the hexagon.
You know, it's really not the prism. It's the circle.
It's the base, isn't it?
Yep. But that means the prism is going to be larger as well.
Right, that's true. So what conclusion can we draw from this?
Well, because it depends on which shape has the largest area.
And the shape of what? That's the base,
Base.
right?
Mhm.
So the prism that has the larger base is gonna have more surface area. And the cylinder has the largest base.
Absolutely.
Okay? The sides are increasing again, aren't they?
Yep.
Okay, so as the sides increase, the base gets bigger.
Right.
Okay? So as the sides increase, the base, the surface area of the base
Mhm.
increases.
And because that happens, the surface area of the entire cylinder increases.
Should we say prism since they're not all
Mhm.
cylinders?
Right.
And the surface
Oh.
area of the prism increases.
So let's read that again. As the sides of the prism increase, the surface area of the base increases, and the surface area of the entire prism
Increases.